Hello students, and you are welcome back to Solve Your Physics Past Question class. Today we'll be looking at the concept of capacitor in physics, as we're going to be solving our questions from West African Examination Council from year 2000 to 2010. The first question I have here with me is from the WAEC past question year 2000. It says a capacitor of capacitance of 2 microfarad is connected to a 10-volt battery. Calculate the charge stored in the capacitor. Now, when you want to solve questions like this, you have to know that the formula or the quantity of charge is equals to capacitor times the voltage. So we have Q equals to CV. Our C is the capacitor while the V is the battery. So from our question, we're given 2 microfarad. Then we're going to convert the 2 microfarads to a farad. We know that micro is 10 raised to the power 6. So we have 2 times 10 raised to the power 6 farad. So that is the unit or the value for our capacitor. Then we have our volts to be 10 volts. So let's plug this into our formula, which is Q equals to CV. So we have Q equals to 2 times 10 raised to the power minus 6 farad times 10 volts. So we have 20 times 10 raised to the power minus 6
coulombs
or 20 micro
coulombs
as our final answer. The next question we have here is from the WAEC past question 2001. It says 2 capacitors, 4 microfarad and 6 microfarad are connected in series. Find the equivalent capacitance of the combinations. From this question, we're told that 2 capacitors were connected in series. But the first thing I want you to know is that when it comes to capacitor, it's the opposite of resistance. So that we know from the knowledge of our resistance, we know that the series formula are connected in a straight line. That is, R total or equivalent of resistance is equals to resistor 1 plus resistor 2 plus resistor 3 as much as many resistors we might be given. So that is for the series of a resistance. But when it comes to capacitor, it is the opposite. So the series of a resistance is the parallel of a capacitor. In this question, we're going to calculate our capacitors in series. So the formula for the capacitor in series will then be 1 over the equivalent of the capacitance equals to 1 over C1 plus 1 over C2, just that we're given the 2 capacitors in these questions. So the first capacitor is 4 microfarad and the second capacitor is 6 microfarad. So let's plug this into our formula. So we have 1 over equivalent of a capacitance equals to 1 over 4 plus 1 over 6. So making 12 the lowest common multiple of this fraction. So we have 3 plus 2 divided by 12. So we have 5 over 12. So that's not the answer. So we have 1 over equivalent of the capacitance equals to 5 over 12. So when we cross multiply, then the equivalent of the old capacitance is equals to 12 over 5 microfarad. And when you further divide this, you'll be having 2.4 microfarad as your final answer, or the equivalent of the capacitor. The next question I have here with me is from the WAEC past question 2002. It says a 5 microfarad capacitor is connected across a 20 volts power supply. Calculate the energy stored in the capacitor. So here we're told to calculate the energy stored in the capacitor. And when it comes to the energy stored in a capacitor, the formula is equals to half CV. So half capacitor times square of the voltage, half CV squared. So we have energy equals to half times capacitor times the voltage square. So from our question, we're given a capacitor of 5 microfarad and we're given a volt of 20 volts. So we can convert our microfarads to 5 microfarads to 5 times 10 to the power minus 6 farads. So by plugging this into our formula, we have energy is equals to half times 5 times 10 raised to the power minus 6 times 20 square. So we have half times 5 times 10 to the power minus 6 times 400. So by multiplying this all together, we then have 1 times 10 raised to the power minus 3 joules. So we can, which can also be further written as 1 millijoule as our final answer for the energy. The next question we have here is from the WAEC past question 2003. It says a capacitor with a capacitance of 8 microfarad is charged to 12 volts. What is the potential difference across the capacitor if it's connected in parallel with another 8 microfarad capacitor? How do we solve this? In a parallel combination, the potential difference across each capacitor is the same. Thus, the potential difference across the parallel combination remains 12 volts, which is the answer to this question. The fifth question, which is the last question we'll be dealing with for today's class, says if the capacitor with capacitance 3 microfarad is connected to a 9-volt battery, what is the voltage across it when it is fully charged? To know the voltage across these capacitors, we must understand that when a capacitor is fully charged, the voltage across it is the same as the battery voltage. Hence, the voltage across the capacitors is 9 volts, just from our question. So this is where we are going to stop in today's class.